Welcome to MATLAB Tutorials, brought to you by Engineerize.com, where we engineer your rise. This week, we will learn how to create and execute a simple script file. A script file is a list of MATLAB commands stored in a file that are to be executed in the command window. It is also called M-file or a MATLAB program. So, a script mainly takes inputs, operates on them to generate an output, and then displays the output. So let's write a program to convert temperature from Celsius to Fahrenheit. Clicking the new script icon, we can open the editor where we type script files. So this is the formula, that is our main operation. The input variable is C and the output is F. One way of entering the value of C is by typing it right here. We'll save the file as c2f.m and run it. In the command window, we see the output value of F. Let's disable this input and instead create a variable c equal to 50 in the command window itself. We can run the script file by typing its name in the command window. This time it uses the already created variable c for the operation. The third way is to seek the value of c from the user using input function. This is similar to scanf and cin in C and C++ respectively. C equals input, first brackets, semicolon. Prompt within single quotes, say enter temperature in Celsius. So we'll save it and see how this works. In the command window, it asks for the value of C using the prompt we provided. When we enter a value, it will be used as C and converted to Fahrenheit. Now, let's learn how to formalize the output. Instead of directly showing the output from the operation, we will print a new line for output using fprintf function. Fprintf, first brackets, within single quotes, %i degrees Celsius is equal to %i degrees Fahrenheit, comma c, comma f. The first percent sign represents the position of the first variable provided here. The second percent sign is for the second variable, and so on. I represents integer notation of display. Let's change this one to F for fixed point notation. And we'll save it and then run it. More detailed formatting of the notations are also available, like fixing the field size and accuracy. Also, let's put a line on the top using display function, saying Celsius to Fahrenheit converter. Let's see how that looks. Now that we have covered the input and output, let's focus on more complex operations, like decision making. Decisions are made based on certain conditions, which are defined using relational operators. For example, greater than, less than, is equal to, etc. Decision making is implemented using if-then-else structure. This is the basic flow process. We start with some variables. We check a condition. If it is true, we execute statement 1. If it is false, we execute statement 2. Let's write a program to determine if a student has passed or failed according to his marks. Let marks equal to 80. If marks greater than 40, fprintf within brackets pass, else fprintf within brackets fail, end. When we run it, as expected, 80 is greater than 40 and it displays pass. You can modify the input part to seek marks from the user. Let's run it again, this time with marks as 30. Instead of determining pass and fail, say we have to determine the grade. In such a case, we can use else if, like this.
Another conditional statement is the switch case structure. Say we modify our previous program a bit to temperature converter, where we ask for current unit of temperature, then convert it to the other two. It starts with switch and then the variable name that we need to check. Then case, one possible value. Say the user enters F for Fahrenheit. In next lines, statements corresponding to that value, like conversion of Fahrenheit to Celsius and Kelvin. After that, a new case, another possible value. Say the user enters C for Celsius, followed by statements to convert it. Then a third case of Kelvin and its respective conversions. Now if the value of this variable or any other expression here matches one of the case, the statement after the case will be executed. There is an optional otherwise. If none of the cases match, the statements after otherwise will be executed. Say display wrong input of the temperature unit, and then the switch case statement finishes with an end. So let's run it. Moving back to our other program.
Now let's say we have 10 students whose marks are available as a row vector. Should we write such statement 10 times each for one student? In such cases, we use loops. We'll learn more next week. Thank you.